Hello viewers, in today's class we are going to take up an important topic in three-dimensional geometry, that is image of a point with respect to a plane. So here we have the problem, find the image of the point -1, 3, 4 with respect to the plane whose equation is x minus 2y is equal to 0. Right? So here let us first draw a rough sketch of this problem. So here we are given the point P, say -1, 3, 4, and we have to find the image of this point with respect to this plane. So let us draw the plane like this, and this is the plane pi whose equation is given as x minus 2y is equal to 0. Right? Now the image of this point P with respect to plane is, say, it lies at this point. Say Q is the image of this point P with respect to this plane. So let us assume that the coordinates of this point Q are say alpha, beta and gamma. Right? Now what we will do, we'll join these 2 points and we get a line PQ, and let us first write the equation or the Cartesian equation of this line PQ. So we know that the equation of this line PQ can be written as x minus x1 over x2 minus x1, y minus y1, y2 minus y1, and z minus z1 divided by z2 minus z1. Right? So the equation of this plane this line PQ can be written as x plus 1. We can take this point as x1 y1 z1 and this point as x2 y2 z2. So we have x plus 1 divided by alpha plus 1. We have y minus 3, then we have beta minus 3 and z minus 4 divided by gamma minus 4. Right? Okay. Now let us have a look at the equation of this plane, and if we look at this equation, we see that the direction ratios of the normal to this plane are given by 1, minus 2 and 0. So these are the drs of the normal to this plane. Right? So if we have the normal like this, then the drs are given by 1, minus 2 and 0. Right? So these are the coefficient of x, y and z. Right? So here we do not have the z component. Right? Okay. Now let us take the point M, which is the midpoint of this line PQ, and the coordinates of this point M can be written by using the midpoint formula, that is x1 plus x2 divided by 2, y1 plus y2 divided by 2 and z1 plus z2 divided by 2. So we can write it as alpha minus 1 by 2, then we have beta plus 3 by 2 and gamma plus 4 divided by 2, right? So the coordinates of this point M are given like this, right? Now this point M lies on this plane, lies on the plane x minus 2y is equal to 0. So obviously the coordinates would satisfy this equation. So substituting alpha minus 1 by 2 for x and beta plus 3 by 2 for y, right? So we have alpha minus 1 by 2 minus 2 times beta plus 3 by 2 is equal to 0. Now if we simplify it, then we have alpha minus 1 minus 2 beta minus 6 is equal to 0, and we have alpha minus 2 beta and minus 7 is equal to 0, right? Now we see that this line PQ is parallel to the normal vector to this plane. So these two lines are parallel, and we know that if two lines are parallel and if their DRs are A1 B1 C1 and A2 B2 C2, then we have the condition A1 over A2 is equal to B1 over B2 is equal to C1 over C2, right? So here A1 B1 C1 are the DRs of PQ, and A2 B2 C2 are the DRs of this normal, right? So the DRs of the line PQ are alpha plus 1, beta minus 3 and gamma minus 4. So if we write here, and for A2 B2 C2 we have 1 minus 2 and 0, right? So we can write alpha plus 1 divided by 1 is equal to beta minus 3 divided by minus 2 and gamma minus 4 divided by 0. So for A1 A2 we have alpha plus 1 by 1. For B1 over B2 we have beta minus 3 divided by minus 2, and for C1 over C2 we have gamma minus 4 divided by 0, right? Now let us equate these ratios to some scalar, say lambda, right? Okay, so now from this equation we have alpha plus 1 by 1 is equal to lambda, beta minus 3 by minus 2 is equal to lambda, and gamma minus 4 by 0 is equal to lambda, right? So if we solve these three equations for alpha, beta and gamma, then we get alpha is equal to lambda minus 1 and beta is equal to minus 2 lambda plus 3, and for gamma we can write 0 times lambda is 0, so we have 0 plus 4, and that is 4, right? So these are the values of alpha, beta and gamma in terms of lambda, right? Now if we substitute the value of alpha and beta in equation 2, then we get lambda minus 1. For alpha we have lambda minus 1 minus 2. For beta we have minus 2 lambda plus 3 minus 7 is equal to 0. Now this is a linear equation in lambda, so we can write it as lambda minus 1 plus 4 lambda minus 6 minus 7 is equal to 0. So this is 4 lambda plus lambda is 5 lambda, and here we have minus 14, right? That is equal to 0. So we have lambda is equal to 5 lambda is equal to 14. So we have lambda is equal to 14 over 5, right? Now once we have obtained the value of lambda, and if we substitute this value here, we can easily find out the coordinates of the image of this point P, right? So alpha can now be written as lambda minus 1, and lambda is 14 over 5 minus 1. So we have 14 minus 5 by 5, that is 9 over 5, right? Similarly, beta is minus 2 lambda plus 3. So we have minus 2 times lambda. Lambda is 14 over 5 plus 3. So we have minus 28 over 5 plus 3, and we can write it as minus 28 plus 15 over 5, right? And this is equal to minus 13 over 5, right? And gamma is obviously equal to 4. So the coordinates of the image of this point P with respect to this plane, it can be given by alpha is 9 over 5, then beta is minus 13 over 5, and gamma is 4. So viewers, this is how we find out the image of a point with respect to a plane, right?